Hello, today we are starting a little bit of a different sprint. We are here in the elements of art shape and we've just finished the simplification tutorial. But now before we get to pixel art scale, there's this thing that I want to kind of address: readability, because as you go smaller and smaller, it's harder and harder to figure out what you've tried to draw. Now, normally you would maybe show it to your friends, show the image, see what people think. But of course, in the app, I can't immediately do that. So it'd be cool if the computer could somehow give you a little bit this kind of a feedback. So how would we do this for readability? Well, I've done a little bit of research, and here I have found a paper called Annotation-Free Human Sketch Quality Assessment. It describes how you can evaluate sketches. They're able to give this scoring. For example, here you can see this sketch is up here. You could barely tell by just looking at the sketch that this is a rabbit versus this. A lot of people will be recognizing it. So I'm gonna try and see what kind of approaches they've been doing to be able to get this kind of assessment. Maybe we won't be able to get exactly this kind of quality, but at least I want to learn how this is done. I have another paper. What I like about this one, because here it shows ambiguity, right? If this drawing, what did you try to draw? An egg, a tire? Like, is it clear enough that this is the thing that you wanted to draw? So it'd be kind of good to be able to give this kind of measures. And using this method, what is also really cool is here you can see actually it can figure out which of the details of the drawing are the ones that are contributing to being able to recognize, oh, that this is a helicopter, these are the important parts. And then you could apply a simplification score. For example, you could be taking this windows out of an airplane and it will still read as an airplane, and that's, you could the computer could judge where on that simplification scale you are. Now, I have no idea how much of this I can actually understand and recreate, but I'm a big proponent of learning on the job. That's one of my pet peeves, is when we are just expected to learn all of our knowledge in university and then just apply it for the whole life forward. I think that's a little bit misguided, because you don't have necessarily the motivation back then when you don't have a concrete problem at hand. So it would be much better that you actually learn these things once you get around to a problem that requires it. But of course, you have to be then very good to actually give yourself the time to then learn when you get to that point. So that's what I will attempt to do. Now, I still don't want to spend too much time, so let's give ourselves until the end of next week for this sprint. We're gonna call this the readability evaluation. Image classification tasks work with neural networks. So we're first gonna explore existing models, and I've done a little bit of looking into it, and there's probably going to be two classifiers. One is a symbolic classifier. What's probably going to be a problem with that is that it doesn't really recognize when you're actually trying to draw something realistically. So you also need to create a realistic classifier. But I'm gonna leave this very open-ended like this, because I have no idea what I'm getting myself into. Worst case scenario, nothing of this is feasible to be put into the game, or I just can't do it. We'll find out. Alright, so I have something going, learning all of this neural network stuff. Wow, the way this is done nowadays, it's quite mind-boggling. You know, when I was learning neural networks 20 years ago in college, we barely scraped the surface, and now you're looking at these Python notebooks that just execute stuff on some hardware in the cloud, and oh my goodness, it's been a journey going through all of this. But first, let's talk about data sets. That's where all of it starts. So for the symbolic drawing, there's this great set called Quick Draw from Google. Essentially, it's been a mini game where it asks you to draw something, and so for I don't know how many, 300 or something things, they have drawings of how people would draw that. So let's say alarm clock. Here is how like 100,000 people have drawn alarm clocks. So this is a really huge data set. It goes for, I think you have 20 seconds to draw something. So this is really the symbol level. What do people recognize as an alarm clock, or a car, or a door, you know? That's immediately what they think of. And then I found another one that are drawings, but they're quite much more realistic. It's this sketchy data set. The difference here was that they showed the participants a photo for a couple of seconds and then they had to draw it. And so, you know, you have much more of a visual representation of how something should look like. So for example, when people are shown planes, for each one of these photographs, you then have a few sketches of how people drew that thing. And so oftentimes they're much more realistic. So while the doors in the quick draw data set are much more simplistic, these ones might have quite much more details depending on what kind of reference that they were showing. So I was able to find some models that are already trained on the quick draw data set. But for this sketchy data set, I had to do it on my own. And so I learned first, I trained one on quick draw myself, see if I can get similar results than this pre-built one. And once I got that down, I tried again with this other data set. And this is how it looks like. So here I've made a little test bed where, you know, if I draw something, it will then let me know on the left what does the quick draw data set thinks this is like. So 42% it's a bracelet, 90% clock. And then on the right is what this more realistic sketchy data set thinks like. So it thinks it's an apple. So, you know, if I go and create this even more realistic, well, this one thinks it's an apple, this one doesn't. And here already it shows one of the things that is quite problematic, this kind of stuff. If I'm gonna be drawing with too thin of a line, then one of them might not work as good as the other. Animal migration, stitches. So it's really important because down here you can actually see what kind of input is going into the classifier. So the line width actually needs to match as close as possible to the classifier. So even if I just do this and make it more thick, see how the apple just shoots up to 70. So there's still quite a lot of work left to be done. I need to train this network so that they are kind of using similar line width. Another problem is that these labels, you know, it has a bunch of stuff. The other one has only 100 of them, and so I'll first have to just find some sort of intersection of the things that both of them have. So yeah, so far I don't think I have anything usable yet, which is a little bit scary. But you know, we have one more week left of experimentation, so let's see if improving these models creates some more usable results. Alrighty, here we are at the end of the sprint, and yes, improvements have happened. Here's my final image classifier training notebook. Let me run you through how a neural network like this is trained. It actually turned out of the 125 classes in the sketchy set and the 300 and whatever in the quick draw, there's an actually quite big overlap. I was able to get 94 things that the classifier can recognize. 94 were in both of these sets. Lots of animals, lots of food, but a bunch of other useful stuff as well. Now, the main thing I wanted to do now is to have exactly the same input for both data sets and for when you're drawing stuff. So I actually went all the way down to the raw data in the data sets, that is the vector drawing. So instead of taking these 28 pre-rendered data sets, I went down to the vectors, got them, loaded them in and rasterized them myself. Here you can see an example of them for an umbrella. So this goes into the neural network, and I further split it down into 80% training data, 10% validation data that is used for measuring how good it's doing while it's being trained, and then 10% test data, which will be then applied at the very end after all the training is done to measure the performance. So altogether we have 750,000 of images going into trainings, and then 100,000 for validation and testing. I've also tried two different models. One is this mobile net that comes pre-built into Keras. This was one of the architectures that would use in one of the pre-trained models that I used, so I tried to recreate it myself as well. But in the end, it actually turned out that just a normal straight-up convolutional neural network that goes from 64 pixels down to 32, 16, 8, 4. It's a deep neural network that in each layer works up from the details, literally from pixels, and then combines it into higher level concepts. And after it then performs training, Boom, gets fed all of these 3/4 million images, adjust the weights in the neurons. Then we get down to testing and run it. And yeah, here, for example, here are the results. On average, around 90% accuracy. And then all there's left is to export all of these weights of the neurons and how they're connected into a file, which then gets loaded in my classifier over here. So let's try it on some clearly symbolic stuff, like let's say a fish. You know, this is, if you tell somebody to draw a fish, they will go to something like this. Definitely symbolic. For the realistic one, it doesn't quite kick in. So now let's try to draw a little bit more realistic version based on this reference over there. There we go, it's a little bit better. Let's see if it's any better on apples like last time. Okay, so it got apples 100% down. I also made it so that right now, as I'm drawing this, it's also recording my vector strokes. And yeah, look at this, now we have a shark. How about we try bread? 100% bread, 40% cup. I guess if it was a cup, it would be like this. How about this realistic loaf of bread over here? Yep, that one is bread. What about sliced bread? Oh, that's a shoe. Could be bread. All right, let's try a realistic couch. I mean, to be fair, it is a little bit like bread once we do this stuff. Yes, 100% couch. Probably this would help as well. Let's see if we can turn this kangaroo into a dog. Please don't judge me on the proportions of my dog drawing. I don't know, maybe if we give you another leg here. Well, at least it thinks it's a realistic dog. So I'm thinking maybe I'll be combining what both classifiers think are the most possible things, like dogs, elephants. Let's go to a little bit more symbolic stuff. So here's a little spoon. Yep, definitely. Oh yeah, let's try some vehicles. To be fair, fish are kind of like this, so let's hope once we add these things, it should be a little bit more obvious what we were going after. And definitely, you know, these are the things that turn something from a fish into a helicopter. Let's try some more without references. You know, if you just ask me to draw a butterfly, saxophone, really? I was wrong, I do need references. Let this be a lesson, why it's always good to draw from reference, or at least as you're learning, so that you know how things actually look like in real life, and you're not just drawing symbolically, as you have been taught when you were a little kid in school. Look at that, 100% way more realistic butterfly. Now I am actually quite happy about this difference, that this might be able to give me a little bit of an idea of how realistic you were drawing something. Mushroom, I think this is how they would teach me in school. And a hat. Pizza. That's what we did in simplification. Could be a pizza, not the most realistic one. But if we draw a much more detailed version for a realistic classifier. Little salami. 2% pizza. 26% hedgehog. So yeah, it's not bad, but it's also not great either. Skyscraper into a candle. It's definitely working much better than it was before, but I'll have to think about how exactly can I incorporate this so that it will be actually useful. Now, one problem is definitely still that it can't recognize everything. In fact, just having it recognize this 100 categories, not ideal. But maybe if I use it specifically for, I tell you what you need to draw, and then it judges how close you got to that specific class. Let's say in a challenge where I can control exactly what you're trying to draw, maybe it can still be useful there. I don't know if I can recognize that this is a fan after I've done all of these lines. Good job, you. So yeah, this is a little bit of a different sprint. Like I said, this is working in my version of Pixel Art Academy, but nothing that I can release yet. So more work to be done with this. But for now, that's it. I'm going on a vacation for a week, and I'm gonna be thinking about this, how to put exactly this into the next challenge. And I will see you in the next devlog.